Hello everyone. Today we will solve few more problems related to flexural strength of PSC members. Today's first problem will start. A post-tensioned unbounded pre-stressed concrete beam of T section having a flange width of 1200 mm and thickness of flange 50 mm. The thickness of web being 300 mm is pre-stressed by 4700 mm square of high tensile steel located at an effective depth of 1600 mm. If FCK equals 40 Newton per mm square and FP equals 1600 Newton per mm square, effective span to effective depth ratio is 20 and effective pre-stress after all losses is 1000 Newton per mm square. Estimate the ultimate flexural strength of unbounded section. So by seeing question we can decide it is post tensioned unbounded section. So since it is unbounded, it will be either case 3 or case 4. Now let us go for section. It is T section. It means it is a flanged section. So flanged section means it is case 4. Unbounded flanged section is case 4. So section details is given: 1200 mm width of flange and 650 mm width thickness of the flange. Web is about 300 mm thick and effective depth it is 1600 mm. So further proceeding, so first we need to find out effective reinforcement ratio and LYD ratio. Case 4 unbounded section, we need to find out both ratios, effective reinforcement ratio and LYD ratio. So effective reinforcement ratio AP FPE by BD FCK. Effective pre-stressing force, it is given 1000 Newton per mm square. 1600 is characteristic strength of the steel used, but effective pre-stressing force is after all losses it is 1000 Newton per mm square. So for that we have 0.0611, that is effective reinforcement ratio, and LYD ratio is directly given in the question. Ratio effective span to effective depth ratio it is 20, so LYD ratio is 20. Now unbounded flanged section, go to table number 12. So first we need to check for 0.0611. So 0.06 means it lies between 0.05 and 0.1. So first we need to find out FPU by FP. Since LYD ratio is 20, refer column number 3. So for 0.05 it is 1.32 and for 0.1 it is 1.26. Now interpolate for 0.0611. We will get FPU by FP value as 1.3067. Same way for XU by D ratio, refer column number 6. For 0.05 it is 0.16 and 0.1 it is 0.32. Now we need to interpolate for 0.0611. So on interpolating we will get 0.1955. On simplifying we will get XU and FPU values. So after calculating this, first compare XU with flange, depth of the flange. So here depth of the flange is 50 mm, but we have XU as 312.8. So that means neutral axis lies in the web. So we need to find out what is the area of reinforcement or area of steel, pre-stressing steel in flange and web. So APF we need to find out, that is area of steel in flange, 0.45 FCK B minus BW into DF by FP. On simplifying we will get 506.25 mm square. So further APW, total area of steel minus area of steel in flange, we will get 4193.75 mm square. So next step, again we need to find out new effective reinforcement ratio. So here we need to use area of steel AP. Instead of AP we need to use APW. Instead of B we need to use BW. So APW FPE by BWD FCK. So new effective reinforcement ratio we will get 0.218. Again from same table number 12, we need to refer for 0.2. Since we have got 0.218 and from table you can see 0.2 is the maximum value we have, so we need to consider the same value only. So for FPU by FP, refer column number 3, it is 1.16, and for XU by D ratio from column number 6 we have 0.58. By considering these two values, we can find out FPU and XU values. Then considering moment equation and substituting all the values, we can calculate ultimate flexural strength of the member, that is 7.16 into 10 power 9 Newton mm. Next problem, the cross section of a symmetrical I section pre-stressed beam is 300 mm by 750 mm overall with flanges and web 100 mm thick. The beam is post tensioned by cables containing 48 wires of 5 mm diameter, high tensile steel wires at an eccentricity of 250 mm. The 28-day strength of concrete in compression is 40 Newton per mm square and ultimate tensile strength of wires is 1700 Newton per mm square. Assuming that the grouting of the tendon is 100% effective, determine the ultimate moment of section as per IS 1343 provisions. Yes. In this case, see, in question he is given it is post tensioned beam, but he is given that grouting of the tendon is 100% effective. So that means you need to consider it as a post tensioned beam with bonded tendons, and here it is given I section, that is flanged section. So case number 2, bonded flanged section, that we need to consider here. So based on the given condition we need to first decide the case, then we need to proceed for the problem. So I section data is written here. So overall width of this flange is 300 mm and thickness is 100 mm as given in the question, and overall depth of the section is 750 and neutral axis lies at 625 mm. Sorry, the position of the tendons is at 625 mm from the top of the section, or you can say eccentricity of 250 mm. So depth, effective depth, since it is symmetrical I section, 750 by 2 plus 250 eccentricity, so it is 625 mm. Next, width of the web, it is 100 mm, depth of the flange 100 mm. AP we need to find out 48 number of 5 mm square, so 48 into pi d square by 4 we will get 942.47 mm square. FP is given, ultimate strength, and FCK, characteristic strength of concrete, 40 Newton per mm square. So first step, it is effective reinforcement ratio, APFP by BDFCK. So substituting values we will get 0.2136. So here one thing you can observe, if it is unbonded member or unbonded section, you should calculate effective reinforcement ratio as well as L by D ratio. So to calculate L by D ratio, length is not given in the question. The span of the member is not given. So that is the one clue he is given. It is bonded section. Along with that, he is giving 100% of effective grouting has been done in the section. So these are the two hints he is given that it is bonded section. You should analyze the question like that. So next, effective reinforcement ratio, it is 0.2136. Go to table number 11, bonded pre-stressing member. So here you have two conditions, FPU by 0.87 FP. There you have pre-tensioning and post-tension with effective bonding. So here you need to refer with post-tension with effective bonding, that is column number 3. So refer column number 1 for value 0.2136. So it lies between 0.2 and 0.25. So for 0.2 you have 0.95 and for 0.25 it is 0.9. Similarly for XU by D ratio, refer column number 5. For 0.2 we have 0.414 and for 0.25 we have 0.488. So after considering these values, now interpolating for 0.2136, we will get FPU by 0.87 FP value ratio as 0.9364 and simplifying we will get FPU as 1384.93 Newton per mm square. Then again for interpolating of XU by D ratio we will get 0.4341. XU value will become 271.31 mm. So the depth of the flange or thickness of the flange is given as 100 mm, so it is greater than DF. So neutral axis lies in the web. So area of steel in flange and web we need to find out APF and APW. After calculating APW we need to find out new effective reinforcement ratio, APW FP by BWD FCK. Again with respect to table number 11 we need to get the values. So here it is 0.4968, but you can observe in the table number 11 the maximum value given is 0.4 only. So directly we need to consider the value of 0.4 since it is post tension effective bond 0.4. We have FPU by 0.87 FP ratio 0.75 and XU by D ratio 0.653. By selecting the values we can calculate FPU, it is 1109.25 Newton per mm square and XU is 408.125 mm. Then considering the moment equation and substituting all the values we will get 574.65 kilonewton meter as the ultimate moment of capacity or ultimate flexural strength of the member. Next problem, an symmetrical I section has an overall depth of 2000 mm. The top flange width and depth are equal to 1200 mm and 300 mm respectively, and the bottom flange width and depth are equal to 750 mm and 200 mm respectively. The thickness of the web is 300 mm. The tendons having the cross section area of 7000 mm square are located at 200 mm from the soffit of the beam. If the ultimate compressive strength of concrete and the tensile strength of steel are 42 and 17560 Newton per mm square respectively, and the tendons are effectively bonded in concrete, estimate the flexural strength of section as per IS 1343 provisions. So again here it is I section, so flanged section, and it is effectively bonded in concrete means bonded flanged section. So it is case number 2. So all the details are given, I section and everything. So area of steel is given, AP 7000 mm square, width of the beam is 1200 mm. So obviously we need to consider top width of the flange. So thickness of the flange is 300, thickness of web is 300, and effective depth. So here the location of the tendons is 200 mm from the soffit. So the remaining depth will be from the soffit, means it is the from the bottom of the beam. The remaining portion will be effective depth of the beam. So overall depth is 200 minus position of tendon is overall depth is 2000 minus position of tendon is 200. We will get 1800 mm as the effective depth. FCK 42 and FP 1750 Newton per mm square. So first find out new effective reinforcement ratio APFP by BDFCK. We will get 0.135. Again go to table number 11 in IS 1343. 0.135, it lies between 0.1 and 0.15. For both we have 1. So FPU by 0.87 FP is equal to 1. So here it is not given whether it is pre-tensioned or post-tensioned. The tendons is given direct tendons are effectively bonded in the concrete. So there is no question of grouting, there is no question of post-tension. So directly we will consider it as pre-tensioning only. Then for XU by D ratio value, we have 0.217 and 0.326. On interpolating for 0.135, we will get XU by D ratio as 0.2923 and we will get XU as 526.14 mm since it is greater than thickness of the flange, which is 300 mm. So area of steel in flange and web APF and APW. Again new effective reinforcement ratio APW FP by BWD FCK. On substituting and simplifying we will get 0.3151. Again go to table number 11. 3151 means it lies between 0.3 and 0.4. So here we have 1 and 0.9. For FPU by 0.7 FP ratio and XU by D ratio we have 0.655 and 0.783. Both values we need to consider. On interpolating for FPU we will get FPU by 0.87 FP ratio 0.9849. On simplifying we will get FPU as 1499.51 Newton per mm square and XU by D ratio on interpolating we will get 0.6742 and we will get 1213.56 mm as the XU value. And on simplifying the values in the moment equation we will get the ultimate moment capacity or ultimate flexural capacity of the member 1.63 into 10 power 10 Newton mm. Next problem. An unsymmetrical I section being girder has the following sectional properties: width and thickness of flange 1200 mm and 360 mm respectively, the thickness of web 240 mm, centroid of the section located at 580 mm from the top of the girder is used over a span of 40 meter. The tendons bonded with cross section area of 7000 mm square are parabolic with an eccentricity of 1220 mm at the center of the span and 0 at the supports. Given FCK equals 45 Newton per mm square and FP 1700 Newton per mm square, estimate the ultimate flexural strength of the center span section used in IS 1343 code provisions. So in this question you can observe it is unsymmetrical I section. He is given only top flange details, that is thickness and width of the top flange, and here it is given the tendons are bonded, so we can consider it as pre-tensioned only. So details are given. Width of the flange 1200, thickness is 360, width of web is 240. So effective depth, here you can observe the distance of centroid from top is 580 and eccentricity means centroid to location of tendon, it is 1220. So overall it is 1800 mm. Overall depth of the effective depth of the beam is 1800 mm. FCK 45 Newton per mm square and FP 1700 Newton per mm square. So first, effective reinforcement ratio APFP by BD FCK. On simplifying, we will get 0.1224. So it lies between 0.1 and 0.15. For both we have 1 and for XU by D ratio 0.217 and 0.326. Considering both values, we can get the values of FPU and XU by D. XU value is 478.344. The thickness of the flange is 360 mm. So XU is greater than DF. So neutral axis lies in the web section. So calculate area of steel in flange and area of steel in web, APAF and APW. The new effective reinforcement ratio, it is 0.2521. Again go to table number 11. So 0.25 means 2521 means it lies between 0.25 and 0.3. So FPU by FP value we have directly 11. We can consider the values directly. And for XU by D ratio we have 0.542 and 0.655. On interpolating we will get XU by D ratio as 0.5443 and XU value as 979.74 mm. Then on considering the equation and substituting all the values, we will get 1.72 into 10 power 10 Newton mm as the ultimate flexural strength of the member at center of the span. So these are few examples with respect to analysis of pre-stressed flexural strength of pre-stressing members. So in later classes we will discuss about design of the flexural members. Thank you.